Welcome back to Chem 4300. In this video, we're going to look at a web app written by Paul Falstad that simulates a string wave with boundary conditions. So this is the web app, and here you can see the wave function as a function of time, and then you can see also as a function of position. So this is a string that's constrained to have zero amplitude at both ends, just like the example that we looked at in class. Now, right now, we're looking at the n equals 1 harmonic, which is represented down here by this amplitude. So I can turn it down, or I can turn it back up here to any amplitude that I want. So I'm going to clear this, and you can see that I can go over here and turn on the n equals 2 harmonic. And so this has some amplitude. I can have positive or negative amplitudes, and that's the n equals 2 harmonic, and you can see the node at the center. Clear this again, go over here, and I can now raise up and see the n equals 3 harmonic, and then you can see the node here and here. And in fact, you can mix any number of harmonics here, and this is some linear combination, a superposition of all these harmonics, and that's the resulting waveform that you see on the screen. Now, one of the things we learned in class was to do a Fourier series decomposition of a center plucked string, and you can take your mouse and click on the string and pull it up, and you can actually pluck it anywhere you want. I'm going to do the center pluck, and you can see the initial decomposition in terms of harmonics is matching what we have. Actually, now let it go, and you can see that that decomposition over here stays pretty much the same as we noted in our lecture on class, and that's because there is no damping in our simulation, nor was there any damping considered in our derivation in class. Now, you can turn on damping in this simulation, so if I turn on the damping here, then as the string will die down, as you might imagine, a real string pluck would too. So here you see the amplitudes are all dying down, and eventually the string will stop vibrating. So you can experiment with this. I'll turn the damping back off, and you can experiment with looking at different Fourier decompositions, so you can see as I change where I pluck, that changes the decomposition. And this is something that you could actually work out analytically, just the way we did in class. And so instead of having the pluck be at the center, you could have the pluck be at L over 4, for example, and you would get a different decomposition of harmonics. And all of this is nicely calculated here in this app. And you can see how this particular pluck, it looks different as a function of time than the center pluck. Now, we also have the possibility for displaying different information about the wave. I'm going to stop this. I'm going to put on, so go clear, and let's just put on, like, say, the n equals 3. If I display, I can display left and right combination. So what am I looking at here is I'm seeing the standing wave pattern is actually a linear combination of a left going wave and a right going wave. We mentioned this in class. And so we see also, as I scroll up here, you can see there's the magnitude of the harmonic that's been excited here. You can also look at the different modes here. So here you can see this is the mode that I have excited, but if I have multiple modes, I'll slide this up here, excite another mode, and there it is. That's its combination in this story. So let's clear this and look at a center pluck. Well, let's just do right here, and you can see those are the two modes I'm exciting. Now we saw that there were higher modes, but they're low in amplitude that he decides not to plot them. But you can see as I go over here and I add my pluck, put my pluck at a different place, I'm adding more and more harmonics, and so you see all 6 of the sort of major harmonics that are contributing to this waveform in this example here. So that's really all I'm going to show you here. There's a lot of things you can do. You could play sound on this. and you can sort of adjust with the damping, and you can add different frequencies for the force and the number of loads, but we didn't really get into this much in class. But I'll let you play with this from here. But this is a really nice app for sort of understanding how all of these different factors come into play.